All right, here we go. 10.1 right triangle problem. Okay. This should be like a good review of our basic trig knowledge. Okay. And so when I say basic, I mean the very basics of it all. Okay. So we remember in the very beginning when we talked about sine, cosine, and tangent in terms of a circle, right? Where your x is your distance from the center of the circle, your y is your distance from the radius, right? And then r is your radius. Okay. Now let's take it back to geometry. Do you guys remember SOHCAHTOA?
Oh yeah,
Kind of, but not really.
No, that's definitely not what it just said. I don't know how we got there. So SOHCAHTOA is referring to your trig relationships in terms of a right triangle. Does that ring a bell? Okay. The only thing is this only works with right triangles. Okay. When you're talking about it, my lovely pre-AP teacher taught it to us as some old hippie caught another hippie tripping on acid. Instead of SOHCAHTOA, but you know, it goes the same. When you're referring to sine of an angle, it's the opposite side over the hypotenuse. So here's our angle. This is what's considered its opposite side. This is what is the hypotenuse, and this is what is your adjacent. Okay. Yes. Okay. The other fact about a triangle that you need to remember is that all angles of a triangle equals what?
360. Not 360, 180, sorry.
180. Angle sum is going to be 180 degrees. So with the right triangle, you're finding a missing angle, you're only having to subtract 90, right? 90 minus what you already know, because your right triangle already takes up 90 degrees of that 180, right? Does all of that sound like old information in your life?
Kind of.
All right, let's apply that old information. Here you have this triangle, and it wants you to find all the missing parts of that said triangle. So I need to find angle B, I need to find side AC and side BC. Okay, the easiest one obviously to start with is angle A, right? Start off with angle A. So the measure of angle A equals what? Because it's going to be 90 minus our given, which is 25. So we're left with 65 degrees. Can you find the missing angle of a right triangle? Yes. C. Okay. Now we're going to go on to sides. So we're going to find side AC. In regards to our given information of 14 and 25 degrees, so this is our hypotenuse. What is the relationship between angle 25 and side AC? What's the relationship between angle 25 and side AC?
Oh, sine.
It's going to be sine. Well, that's the trig ratio, but the relationship is that this is opposite of it, right? And because it's the opposite of it, that means in order to solve for it, I'm going to use sine because I have my opposite and my hypotenuse. Does that make sense? Yeah. Okay, so side AC equals the sine of 25, which equals what? Well, not, which is going to lead to that, not equal. To find it, it equals opposite over your hypotenuse. I'm going to write opposite over my hypotenuse, which is 14. So if I'm looking for that opposite side, what do I need to do? I'm going to multiply both sides by 14. So I get 14 of sine 25. And that's going to tell me the measure of AC. Does that make sense? So I'm going to go to my calculator, and with my calculator, I need to make sure that it's in degree mode since my theta is in degrees. So I'm going to go to mode, switch from radian to degree. And now I'm going to type in what I have. I need to find 14 sine of 25. We're going to round to the nearest tenth. We'll just put 5 and 9/10. So roughly the approximate value is 5.9 units. Yes?
Yes.
Okay, all right. Now, this time we need to find BC. And so we're looking at BC now. And the relationship between 25 and BC is what? Adjacent. So now I have my adjacent and hypotenuse. So adjacent and hypotenuse means which trig ratio? Cosine. So this is going to lead me to using cosine of 25, which equals your adjacent over your hypotenuse, right? And in this case, our adjacent, we do not know, but our hypotenuse is 14. So if we want to get our adjacent by itself, what do we need to move? We're going to multiply by 14. So when we multiply by 14, we get 14. Cosine of 25 is going to tell us the measurement of BC. So we go to handy dandy calculator, and we are going to do 14 cosine 25. And what do we get? We'll do 12.7 units. And there are two unknown sides. Now, looking at what we did in the math, was it terrible?
Yeah. No, I'm being.
We know. It was not, right? Now, what tends to happen here is that you're not getting a geometry problem anymore, right? It's not going to be straightforward, find this right triangle. Guess what it's at this point?
Trigonometry. Find the length of the shadow, the building cast.
Oh my gosh, look, real world situations, applications of right triangles, what we're going to be looking at. Okay. You guys do just fine when it's straightforward math. However, you freak out when it's a word problem. You freak out, and I don't know why. I have no clue why. But you can do the math, and you proved it just by doing example number 1, right? All right, so we're going to work through this together, and yeah, we can do it. So the altimeter of a jet approaching O'Hare Airport in Chicago reads 5,900 feet as it passes directly over the Sears Tower. At the same time, the angle of depression from the plane to the end of the runway is 5 degrees. How far is it from the base of the Sears Tower to the runway? Okay, great question. So first, we're going to acknowledge what it tells us. It says that it's 5,900 feet. So this right here is our 5,900 feet. Agreed? Okay. Now let's talk about angle of depression. Your angle of depression, it is the distance between the horizontal and at your peak. So this is your angle of depression. This is what is 5 degrees. So this is our angle of depression. Okay. So if this is our angle of depression, what is the value of the inside? Other way around, but yes. 90 minus 5 is going to put us at 85 degrees. Okay. So now I've labeled everything. I took all the information from the problem. It's asking us how far is it from the base of the Sears Tower to the end of the runway. So we're looking for this distance. So related to our given information, Bume and Bume, what are we looking for? We're looking for our opposite. And because we're looking for our opposite and we're given our adjacent, what did you say it was? It's the tangent. We're going to be using our tan ratio. That's because tangent equals, tan theta equals your opposite over your adjacent. Okay? So we're going to fill in everything that we have and solve for what we don't. So we know that tan of 85 equals, do we know our opposite? No. But do we know our adjacent? Yes. So what do I need to do to solve for the opposite?
First multiply by 5,000.
Multiply. What were you gonna say?
Yes,
Okay, so to find our distance, it's gonna equal 5,900 times the tan of 85. Which is gonna give us approximately 5,900 tan of 85. And we get, let's say, 67,437 feet.
Yeah.
Are we cool with that?
Absolutely.
All right, so 67,437. That's a weird 7. Couldn't even play it off. 37 feet. Is how far the airport is from Sears Tower. And if you want to see how accurate or approximately close we were, you would divide this by the number of feet to get the number of miles and then check them out at this point. But for our problem, this is where we are. Okay, terrible. Okay, so this one, I was nice and gave you a picture. Oh, guess what you're not going to get?
A picture.
Oh my gosh, you're not getting a picture, which means you have to
Draw one.
draw one yourself. Okay. At 10 a.m. on April 26, 1998, when none of you were born. Why would you have been born? You're okay. A building 300 feet high casts a shadow 50 feet long. What is the angle of elevation of the sun to the nearest degree? Okay.
First of all,
Have you ever seen those videos where it's like these math equations that don't make sense? That's what that sounds like. It sounds like we're trying to do a science problem that's actually a math, but it's a reading.
So I actually did a similar project when I did
Physics?
my co-teaching with Tennyson. I was at Tennyson and we took mirrors outside to try to estimate how tall Tennyson was using the shadows and the reflections. And so it can be applied.
For such an age.
visuals, first of all,
But-
you cross out unnecessary information. You don't need 10 a.m. as a date.
You do not. I'm glad you noticed that.
My bad.
Okay,
But how was, yeah, I was supposed to know what 10 a.m. is.
The angle of elevation is at 10 a.m.
or roughly, I mean,
Well, 12 o'clock is 180.
but it's not gonna be the same for every point. Your location also matters.
I really like, no, I like the circle.
Wait, is 12 o'clock 0 or 180?
12 o'clock is 90 degrees.
Yeah. If you're seeing, it's been right there the whole time.
Well, but like.
If
it's
you forget, you
right
can look
as-
up there also.
Oh, wait, because like this is a square.
All right,
Anyways,
Oh, okay. Alden, there's literally a clock up there with the radian values on it.
I'm not gonna apply radian value to.
Let's say you're right
Half
now.
east and west.
Okay.
Oh, I got it.
Sun's right here.
It's 90 degrees for a half square,
all right, Alden.
and we're only at.
Did you say half was square?
I'm not gonna bother trying to explain how I figured.
Okay. All right, let's just draw our building, okay? Our building is 300 feet tall, right? I don't know. It felt right. Okay, your shadow is going to, well, then draw your building on your right side. Your shadow is gonna cast 50 feet.
that's a small 50 feet.
I try to be proportional, guys.
You could do the.
I tried.
Parentheses, not proportional.
I try to be proportional. All right, and then you're looking at your angle of elevation. Your angle of elevation is coming, you're rising from the ground, right? So this is your, who?
All you just looked at it and said, I'm very triangle. And you didn't even draw a right triangle. It's a triangle.
That's not a right triangle.
That
It
is
is.
a right triangle.
It is.
Why would we not be dealing with right triangles?
What's that in there?
My theta, it got a little weird.
Do you know the right triangle?
Yes, I know the right
You
triangle.
clearly don't. All the angles.
All right.
And I saw it.
Anyways, here we go. So in this problem, we're not looking for a side. We're actually looking for an Angle, so because it says angle of elevation, right? So I'm gonna still acknowledge what I have. So in terms of this angle, what is my given information? I have I am gonna use tan because I have my opposite side and my adjacent. Agreed? So we know that tan of theta equals opposite over adjacent. And for this problem, my opposite is 300 and my adjacent is 50, which equals what? 6. Do we agree? So we know that tan theta equals 6. We've talked about before, when you're looking for an angle instead of a side, what are you using? If I'm looking for the angle,
Oh, inverse.
I gotta use inverse. So because we do not know our angle, we need to use the inverse. So to get theta by itself, we have theta equals tan inverse of 6. This is my exact value. The calculator is going to help me find my approximate nearest degree. So we're going to go second tan, and we're going to type in 6, and what do we get? We get 80.5, but it says nearest degree, so approximately 81 degrees.
80.5. It didn't add.
It said nearest degree.
You don't even know how to drive a
All right.
Yeah, 3, I saw, then you drew, first off, you drew 2, I drew 1 on your page, you watched me do it.
All right, so let's talk about the difference between the two problems. So in the first word problem, we just used tan as tan, right?
Yeah.
That's because we were looking for a side. And the second problem, we used tan inverse because we're looking for our theta, our angle. Do we see the difference? Yes?
Yeah.
All right. The last one. So the last one here, we have at a point 125 feet from the base of a building, the angle of elevation to the 3rd floor is 22 degrees, and to the 10th floor is 53 degrees. How much higher is the length? How much higher is the length of the floor than the third? Length is the 10th floor. I see it. The 10th floor. I was like, there's no where this says length. The 10th floor, then the 3rd floor. Okay. So here's our building. We're going to label our information based on the building. It says at point 120 feet from the base of the building. So from here to here, it is 125 feet. Agreed? All right. To the 3rd floor, my angle of elevation is 22 degrees. That's going to take me to the 3rd floor. To the 10th floor up here, 10th, my angle of elevation is what? 53 degrees. So this whole elevation is 53. Does that make sense? Okay, I had someone last period add them together. Don't do that. Okay, so what I want you to do at your table, you're going to find the height of 3rd floor. You're going to find the height of the 10th. And then you're going to find their difference. These are your 3 things you need to accomplish. Height of the 3rd, height of the 10th, and then find your difference. Let me know if I can help you.
Oh, you're saying gonna do that?
Yeah,
Oh.
you're going to work together and do it. You got this. Let's see how we did. So for the height of 30, what the height of 30, the height of the 3rd floor, what did you guys use?
Tan.
Use tan, good. So you should have used tan, and we had tan of 22 equals opposite, because we do not know the height, right? Over 125. So for the 3rd floor, to find its approximate value, you should do 125, 10, 22. What did we get?
55.5.
55?
Yeah. Oh, I mean 50, sorry.
I was like, I don't think it's
No,
55.
it's 50.
Okay. So we're at 50.5.
I just read
Did you talk about
It didn't say how to, those are degrees, yeah. Okay, so these are those feet. And then for our 10th floor, we realized that it's pretty much the same thing, right? The only thing that changed was the what? The degree, your elevation, right? So we should have had 125, tan of 53. So we did 125, tan of 53 degrees. And you should have gotten 165.9 feet. Okay, then it asks, what is the difference between the two floors? So I'm just gonna arrow up, hit enter, subtract, arrow up, hit enter, subtract, finally subtract, and we get that the difference is approximately 115.4 feet between the two floors. How did we do? Good?
Yeah.
Doable? All right, 10.1.
What's the first problem?